4.4. Today we're going to talk about series. Series are numbers in a list added together. These can be either arithmetic or geometric. It goes both ways. Okay? So we can work with it being finite, which means our list stops at a certain number, or we can work with it being infinite, where it keeps going forever and we have to add it together. I'm going to do both. So we are going to start off with, when we're talking about adding numbers together, that's where that summation we talked about the other day comes in. Right? We're going to be using the summation notation to write our formulas. Yeah. Oh, I can't spell. Hold on. Formulas. There we go. Okay. So, I can actually jump right in the first one because it's going to take us back to 9.3 in the first section. So, example number 1 from your homework today, it is asking you to write it in summation notation. And this is going to be like numbers 1 through 6. Or technically you guys are doing odds, so 1 through 5, right? And so here is the first one. I'm going to start with an arithmetic one. So let's start off with, let's say I have -8. That's a plus in the middle instead of a comma, my bad. -8 plus -1 plus 6 plus 13 plus. And then I'm going to go out to 27. Alright, so the whole idea is that we're trying to write it in this notation. Okay? So before we can do that, we've got to figure out what our explicit formula is. So we are adding how many every time, first of all? 7. So when we talk about this, since we're adding each time, it follows this: a sub n equals a sub 1 plus n minus 1 times d, right? We know our first term is -8 plus n minus 1 times d, and you guys said it was 7. This is what's going to go behind the e. That's our formula we're using. Now we can simplify this, which I want to talk about too. If I go ahead and distribute, so 7 times n is 7n, and 7 times -1 is -7. So really my explicit formula is 7n minus 15. That's going to go behind my summation notation. Since I'm using the variable n, I'm going to start at n equals 1. But here's the tricky part. How many terms am I going to? It's not 27 terms. That's the last number.
Uh-oh. So 6.
1, 2, 3, 4. You're right, if I add 1 in here, there's 5 and there's 6. So 6 in this one. But what if it wasn't that easy to figure that out?
Put in your calculator, and then you write whatever you put in your calculator on your paper for an answer.
So I want to talk about how to figure that out. Okay, we did these. This was, again, if you backtrack to Wednesday on your homework, it was problems 29, where it gave you a certain, like, I don't know, it said it was the 2nd and 5th or something, and gave you a number. You had to figure out, right, we had to use our formula in reverse. We're going to do the same thing here to figure this out. So let's say it gives some numbers and we didn't know what number 27 was. You can actually use this formula to figure it out. 27 equals -8 plus n minus 1 times 7. And we're solving for n, right? So we have 27 equals -8 plus 7n minus 7. So on this side I have negative 15 plus 7n. I'm going to add 15 to this side. So I get 42 equals 7n. So n equals 6. So it is possible to find what needs to go on top of that sigma notation, okay? So let's do another one like that, because it's not going to be that easy for these problems. Let's try this one. Example number 2, same section. So if I give you 2 plus 4 plus 6 plus 8 out to 70. So first thing we probably need to do is figure out what number term is 70.
Well, 2.
You are not going to count all those, Goofy. So we're going to start with our formula, which is 70 equals the first term plus n minus 1 times the difference, which is 2. So I have 70 equals 2 plus 2n minus 2.
I got it.
What is it?
35.
It is. Very good. So n equals 35. Now the wonderful thing about doing this or finding the n1 first is you actually have found your formula for your explicit formula, right? So when we write our summation notation, we start at n equals 1. We go to 35. And inside our e is this formula we have, which in this case is just 2n. No. So just in the first section, I'm just asking you to like write the notation for it. That's it. Okay? Well, for the first section, yeah, you're just using that formula because it's adding every time. So that's our basic formula for the pattern, right? Okay, other questions? You guys want another one? Another one? No? Okay, I just wanted to make sure. I don't want to, don't want to jump ahead or anything. All right, let's go to the next section.
Example 3.
Yeah. No, before I do example 3, let's do a little chit-chatting. All right. So I want to talk about our formula to find I want to make sure I'm doing the right one. Okay. So what if I want the sum of the sequence without having to use E? What if I want to try it without that? I have 2 formulas for you, okay? So the first formula is if it is arithmetic. We're going to use the formula n times a sub 1 plus a sub n divided by 2. If it is geometric, the formula we're going to use is a sub 1 times by 1 minus r to the n divided by 1 minus r. These are going to find us the sum. Okay? So let's do a sum. Example number 3 using these formulas. Example number 3, right? I'm on 3?
Yeah.
Alright. Let's do this would be 7 through 12. Or numbers 7 through 11, excuse me. So let's do something like, how about negative 7, negative 3, 1, 5, and 9. And let's go one more. 13. So I'm actually giving you all the spots right now. Okay? Because I want you to plug in this formula and see how it works. So first of all, n is the number we have. We have 1, 2, 3, 4, 5, 6 of them. So 6. Then, the first term is negative 7 plus. This is the last term, which is 13 divided by 2. So we have negative 7 plus 13 is 6. Divided by 2 is 3. So 6 times 3, which is 18. Okay? So using this formula instead of the sigma notation is another way to do it. Do another one. Still from the same spot. Example number 4. Let's make it a little tougher. On example number 4, let's go with... I have 111, I have 108, how about 105, and then it goes all the way down to 27. Uh-oh. I don't know what number term that one is. So, we've got to figure out what to do, right? We have, our last term is 27.
I got it.
What is it?
37.
Think so?
Yeah, that's what I think.
Okay, well let's calculate it and find out. Our first term is 111 plus n minus 1 times the difference, which is negative 3. Yes, sir?
Stephanie Gerber has not come in today to test, and she can't run tonight unless she does.
Oh, okay.
So.
All right, thank you very much. Appreciate it.
Yeah, I hope you're freezing good.
Alright, so here we have 27 equals 111 minus 3n plus 3. You thought they're being silly. Combining like terms together, we get 114 minus 3n. So then I'm going to subtract 114 to this side. Good. Negative 90 equals negative 3n, so n equals 30. So Tyler was close. So we know our n is 30. So now we're going to put it into that formula I gave you. We have 30 times by the first term plus the last term divided by 2. So in here we have 138 divided by 2. 69, so we have 30 times 69, which is 2,070. Alright, questions on how to do those? Those aren't bad? Okay, so now let's try the geometric one. Okay, let's go to example number 5. Example 5, and of course this will cover 13 through 15. We're in text. I'll throw it right in there. Thank you, Lily. I appreciate it. Yeah, my husband sent me a text a little while ago that it was snowing in FedEx. So we should have just had our meet last Wednesday, but yeah, so it's what it is. We're going with it. Alright, so in this one, we are going to find the sum. And let's go with, how about 5, 15, 45, all the way out to 98,415.
Yeah, I'm not counting that.
I know. So I threw that up here. So first thing we have to do is figure out what number term is that, right?
Times by 3.
So remember that when we're doing geometric, because that's what this is, we're timesing by 3, that is a sub n equals a sub 1 times r to the n minus 1. So we have 98,415 equals 5 times 3 to the n minus 1. So to solve for this, the first thing we do is divide by 5, right? Divide both sides by 5. If we divide by 5, I get 19,006. Thank you. Equals 3 to the n minus 1. Now tell me, what can I do to solve for an exponent? Yeah, we can use log or we can use natural log right in there. Thank you, Tyler. So, do we want to use log or natural log? It doesn't matter. They're both the same. Alright, so we're going to put an ln in front of both sides, right? So we have the natural log of 19683 divided by the natural log of 3 equals n minus 1. So grab your calculators, type this in. It's on the left. Type in that button on the left next to the 4. It should be 9 equals n minus 1, which means n equals 10.
What did I say, Michael?
So now our formula. Remember that the formula I gave you at the top of this page was a sub 1 times 1 minus r to the n over 1 minus r. So our first term was the number 5. So 5 times 1 minus r3 to the 10th divided by 1 minus 3. That's the rate, that's the r. That's how much we were multiplying by each time? Yeah. 5 times 3 was 15, times 3 is 45. Yeah. Alright, so you can type this in all at once, so you can do it in 2 steps, totally up to you. I got 147,620.
I got the same thing.
Good. So glad to hear that.
Yep.
Alright, so this is good? Okay. Next example, I'm on what, 5, 6? Holy cow, I'm talking a lot today. Example number 6. On example number 6, this is 17 through 21. Yeah. I know, you gotta go. 17 through 21, it says to find the sum. But this time, in this section, it's not telling you whether it's arithmetic or geometric. Okay, so first, determine if you're adding each time or multiplying each time. Okay, then you decide from there. So let's say I have -3, 3 halves, -3 over 4. And I'm going to tell you it's going out to an 11th term. So looking at that, am I multiplying or am I adding? We're multiplying, exactly. So we need our first term, which is 6, and we need to know what our r is. What is it we're multiplying by? Yeah, -0.5 or -1/2, either way. Okay? So now we're going to plug in our formula. Our formula again is we have our first term times by 1 minus our r, which is -1/2, to the 11th, divided by 1 minus our r. So I would, if I were you, just type that in your calculator. Should get a decimal out. I got a total of 4.0019. See if you guys get the same thing. Type it in. Make sure you have all the parentheses in the right place. It's up to you whether you type it in as a fraction or a decimal. Totally good either way.
Oh, mine says error. Should I do the letter or number for Monday?
Okay. Okay. Alright, so I only got 2 more things to talk about very, very quickly. Huh? Alright. So, everything we've done so far, they've been finite series, right? Or sequences. They've stopped somewhere. But what if they don't? Yes, it diverges. So if it diverges, we need a different equation. I knew you'd be excited about that fact.
Oh, yeah.
If it is an infinite series, we're going to use this formula. A over 1 minus R. That's it. Okay? So for example, example number 7, I think. We are doing, would be what you're doing for 25 through 30. If it's diverging, we've got to use this equation. So for example, if I have 4 plus 4/3 plus 4/9 plus 4 over 27 plus, and then just get dots that go forever. And I want to know what the sum is. You're going to use 4 over 1 minus. And what is our R? 1/3. Good. We're multiplying by 1/3. So we get 4 over 2/3, which you multiply by the reciprocal. You get 12 over 2, and so you get 6. Alright, last thing. How to write a repeating decimal as a fraction. Repeating decimal. A repeating decimal is thought of as a series. Okay, so for example, if I have 0.212121 and it repeats forever, right? It is really saying that I have 0.21 plus 0.0021 plus 0.000021 and so on. Okay? So it does follow this A over 1 minus R. Follows that same formula. It's going to take our first term, which is 0.21, and put it over 1 minus 100. So what I want to say is when you have a repeating decimal, the shortcut, I want you to use the shortcut. Okay? Easiest thing to do is if it is repeating 2 decimal places, which is 2 of them, you're going to take 21 over, and then however many digits that is, you subtract 1 from it. So we're going to go 99. And then you're going to type that in and mash enter to reduce that to 7 over 33, I believe. Okay? So, what if I had 0.345? You'd take the number that are repeating, 345, and put it over that many 9s, 999. That's it. Yeah. So you're always going like 1 less. Yeah. So when it's doing it by decimals, it wants you to subtract 0.01, you know what I mean, because you're going that far. It's just easier to say it's 100 minus 1, or however many this number is, you know what I mean, minus 1. So like this is like in the hundreds, so it's 1,000 minus 1 gives you 999. To me, that's the shortcut. Alright? And that's what the last couple of problems are, and you're done. Question? Okay. Sorry today went so long, I apologize. My bad. It's okay, you forgive me?